2050, we were in the future. Yeah, somebody would have been in the future.
So I hope you enjoyed that Back to the Future Part 2 clip. I thought it was a little fitting because we're going to be talking about forecasting. And I am going to be talking about carbon dioxide emissions for energy electric power sectors. So if you didn't know what that means, pretty much I looked at the total energy of different kinds of fuel sources. So if you look at the pie chart, coal is the highest and the others are not so much. So about the data, the source I used was the United States Energy Information Administration, also known as EIA. The units that my data was in is million metric tons of carbon dioxide. So I didn't know what that meant exactly at first, but I did some Google magic and it turned out that's about 2,200 pounds. So a lot of carbon dioxide. It's monthly data from January 2010 to 2015, and I forecasted from February 2015 to July 2015, so just 6 months. So a business scenario, I want to see if there is seasonality in the electric power sectors and which month uses the most energy. A company could use this data to reduce their ecological footprint and promote themselves as a green business. This could be included in a company's Form 10K to give investors a clue of what's going on in their company and the goals of becoming a green business. So I looked at my data and thankfully there was some seasonality. You can tell that some months are higher while others are lower, and the regression line just isn't doing that justice. So I looked at the quality of my regression. The R-square value isn't so hot. Only 6.7% of the variation in the period is explained by the total energy electric power sector of carbon dioxide emissions. The R-square was close to the R-square, but it's still not very good. However, the data is significant. It is below the alpha of 0.05. So I got some seasonal factors to determine my seasonal forecast. Just right away, I noticed that April was the lowest and July was the highest. So the highest and lowest months. So using the forecasted data, the highest months were July, August, and June, so in the summertime, and the lowest was in the winter and spring, so April, November, and March. So I plotted my seasonal forecast against the actual values and the regression, and you can see the seasonal forecast thankfully fits the data a lot better. And you can see my little forecasted bit at the very end, and it's going up just like predicted because July is the highest. So looking at the errors, you might want to pause the video for the next few slides. There's a lot about errors and graphs. So regression is always in purple and seasonal is always in green. So looking at the graphs and the errors, so the mean squared error, mean absolute deviation, mean absolute percent error, and tracking signal were all lower for the forecast data. The mean absolute percent error was in the very good range. It was below 10%, which is awesome. And the tracking signal, there was only one value outside of the range of the -4 to 4 range. Get a little bit more on that in a second. So without failure, you can't really have success. So it's not always a straight, pretty line. So failures. The mean error was not exactly 0 for the seasonal forecast, just a little bit above. So I am undershooting actual observations here. The tracking signal. The original regression forecast had 5 variables outside the range, which is quite a lot, but the seasonal forecast only had 1. So I did not have to use seasonality smoothing techniques, because I had some seasonality in my data. But for funsies, I included 2, the 6-month moving average and exponential smoothing. They were both around 13%. And the seasonal forecast is 3.2. So I am definitely using that for the mean absolute percent error. And you can see that the seasonal forecast fits my data a lot better than the smoothing techniques. So in conclusion, there was seasonality in my data. The highest months were June to August, and so companies should try to reduce carbon dioxide amounts during those months. The predicted forecasts are below, and the error technique I used was the mean absolute percent error, because it was 3.2%. Didn't work out. Kind of, not really. I was just undershooting a little bit by 10 million metric tons of carbon dioxide. Thank you.